Hello. In the CA Quantitative aptitude test that you have for your foundation, you have a topic by the name of logarithm. Now, this is a topic which intrigues a lot of children because they are not able to understand the fundamentals and they find it overwhelming. Well, I'm going to help you here. So let us first understand by trying to decode this. What is logarithm? Is it a single word? No. It's actually two words which have been jumbled up together. Both of these words are Greek words. The first being logos, which actually means principle. Right? That means some theory, some concept, right? Not like the principle that you had in your school. Okay. Now the second is arithmos. Now this is for a number. That means when we are wanting to study logarithm, we are actually wanting to study the principle of a number. Now, this in itself can be pretty intriguing a definition, so I'll quickly try to tell you another definition which will make you understand logarithm in a better way. For that, I want to make sure that you write along with me, because in writing you will understand more. Moreover, you will also be able to remember it for a longer duration of time. So, what is logarithm? Logarithm is the power or index, you can say, or you can even say exponent, to which a number, now you can assume this number to be, say, some a, is raised so as to get another number right, which say can be some c, right? So what we're wanting to do here is we're actually talking about some indices, and we're trying to convert that in the language of logarithm. For that matter, if you talk about logarithmic representation of a number, or if you talk about the exponential representation of a number, they are inverse of each other. That means they are antagonistic, right? And how are they is what now I will represent. So if, say, you have some a which is raised to the power b, and that is equal to c, right? This is the exponential form. Now in the exponential form, what happens is you multiply a number with its own self for a specific number of times to get another number. For that matter, if we multiply 8 with 8 with 8, that means we've multiplied 8 with its own self for 3 number of times. You will write it like 8 raised to the power 3, and obviously when calculated, this will give you a specific result, right? Now if you were to write this in the logarithmic form, what you will do is you will now write log, right, keeping the base to be the same. Now you will write log of c, which will become equal to b. Now this clears the air, as now you can see that you're talking about logarithm is the power to which a number was raised so as to get another number, right? So that is how now we have a raised to the power b, which was equal to c, which was the exponential form. Now we have the logarithmic form, which is when we have log of that number, right, which has been got now as c. We are finding out log of that, right? And we keep the base to be the same to get the index, right? Now I'm sure the meaning of logarithm must be clear with you, right? And this form of writing any number is actually the logarithmic form, right? Now children, there are a few rules that we have in logarithm. Like if you talk about logarithm which has its base to be 10, right? Like if you talk about some log of 401, right, which is to the base 10, then this actually is known as the Briggsian, right, or it is also known as the common logarithm, right. For that matter, a logarithm is also abbreviated to be just log. So in place of writing logarithm, you can even write just log. Now, if the base is e, right, that is, if in place of this now you have the Euler's constant, that is small e, to be the base, right, then it is known as natural logarithm, right. So we can be having, say, anything like log of 43 upon 2, right, to the base e. Here, like I told you, this is natural logarithm, right. Now, what is e? Like I told you, this is Euler's constant. Euler was a mathematician, right, and you have the constant in his name. Now I'll tell you actually what this is. Now if you talk about the Euler's constant, right, that is e, it's equal to 1 plus 1 upon factorial 1 plus 1 upon factorial 2 plus 1 upon factorial 3, and all of that, children, continues up to where? Up to infinity, right. Now it is very easy to calculate this, although you find that this is never ending because this is reaching infinity, but you can get an approximate value out of this. Like if you talk about the first number, it is actually 1, right. Now if you talk about the second number, it is also 1. Now if you talk about the third number, it is going to be equal to 0.5. That is because whenever you talk about, say, some factorial 5, that will be equal to 5 into 4 into 3 into 2 into 1, right. As such, if you talk about factorial 2, it's actually 2 into 1, that is 1 upon 2, and 1 upon 2 will become equal to 0.5. Now if you talk about the rest of the numbers, they actually are decrementing, as you see that the denominator is increasing. Now if you talk about the next term after 1 upon factorial 3, that is going to become equal to 1 upon factorial 4, and as you see that the denominator now will be becoming 4 into 3 into 2 into 1, so it's become larger than just the earlier fraction, right. As such, its value will keep on decrementing and becoming lesser and lesser and lesser. As such, now approximately all of this, that means from 1 upon factorial of 3 onwards, comes to approximately 0.2, right, and as all of this is 2.5, right, so approximately the value of Euler's constant is 2.7, right. Now when the base of the logarithm is this Euler's constant, right, that is e, then we say that we have a natural logarithm. Now after this, children, I'll give you another new term, right, which might be asked in the competition. Like suppose if you talk about log, when you're talking about the base to be 2, right, and then, children, it is known as binary logarithm, and this is normally used in computers as there we use a base of 2, as we have just two numbers, 0 and 1, where 0 means off and 1 means on, right. These are actually different voltages which show you whether the input is a 0 or is a 1. Okay, so all of this that I told you is what was actually first found out by John Napier. He was a Scottish mathematician, right. So all of this I'll just quickly discuss all over again, so that if there is any confusion, right, all of that gets cleared and you have a good idea from the beginning about this topic that we are studying. So we are talking about logarithm. This is in your syllabus for the foundation CA course of numerical or say quantitative aptitude, right. And here in logarithm we actually don't have a single word. This is actually a join of two words, the first being logos, which means principle, and the second is arithmos, which means number. So whenever we are talking about logarithm, we are actually wanting to talk about the principle which governs a number. Now this is a little dubious a definition, so we come over to a less ambiguous definition, and that is a logarithm is the power or the index to which a number a is raised like this, so as to get another number like this, right? So here this is the logarithm, that is, this is the value of the logarithm, right? And here what have we done is we are talking about log of c, that means whatever was the value, right? And the base remains to be the same. Now remember one thing, children, that if you talk about this form of representation, as you know that this is the exponential form, we talk about b to be the exponent, or it is also known as the index, or it is also known as the power. And if you talk about this a, it is the base of this exponential form of a number. Now here too, when we talk about the logarithmic form, we have a, which is known as the base, right? And then we find out the logarithm of this number to be able to get to b, which is its value, right? So I'm sure this definition would have made more sense, and now you've been able to understand what logarithm is. And another way of thinking it is that the logarithmic way is one of the forms by means of which you can write a number, and the exponential form is another way of writing a number. Now if we have the base of the logarithm to be 10, then that will be known as a Briggscian or a common logarithm. Now if the base is e, which is Euler's constant, which is further 1 plus 1 upon factorial 1 plus 1 upon factorial 2 plus 1 upon factorial 3, and all of that continues up to infinity, where the terms from 1 upon factorial 3 onwards to infinity is 0.2 approximately, then the first three add up to 2.5. As such, approximately the Euler's constant comes to 2.7, and if that be the base of the logarithm, then the logarithm will be known as a natural logarithm, right? Next, we also discussed that if we talk about the base of the logarithm to be 2, then it is known as binary logarithm, and this is normally used in computers where actually we have just two numbers, zeros and ones, right, which are known as the bits, and arranging the bits we get data, be it data which is of a picture type, be it data which is of a number type, right, or it can be data of any type. They will always come in these two bits, that is either 0 or 1, right? Okay, next, after looking up all of this, now we'll directly get to a sum, right? And wherever a new concept will be required in times to come, I will be giving that to you. Why am I doing this? That is because I know that you people have studied this topic earlier in some junior classes like class 8 or probably class 9, right? And you're just revising this. So I know that you have the basic concepts, but you require strength for this competition CA, or probably it can also be for competitions like NDA, CDS, banking, or say the examinations with which you export yourself, that is ACT or SAT, right, etc. Okay, so now children, looking up this sum that I have for you people, and that is this. Okay, so the question is an interesting question. You have this as if log of QR to the base p is equal to a, right, and all of this further, then you have to prove this thing, right, to be some specific value, which actually I turn and twisted it as a multiple choice question, as is normally asked in your examination. So there are 4 answers out of which you have to choose one, right? So obviously that can happen not just by telling that this probably is an option out of the way, but actually you got to solve it and get to the correct answer, right? So now I'm giving you people a little time for trial, right? Although as you all are online, so I know that you will be able to give yourself more inflated time, and then you will try it out more seriously. At this time I can only give you 10 seconds. You can pause this for a longer duration of time and try it out. Okay, before I continue further, I'd like you people to sit on a table and chair such that you're seated straight with a neutral spine, not unnecessarily giving pain to your spine by keeping it too straight, right? Further, make sure you don't pick up the writing material, the copy, the pen, etc. when I am explaining, till the time I don't complete my second explanation of the sum, which I normally give so that there is surety of you understanding. Please don't pick up the writing material and just focus where exactly I am. If I'm at R, be at R. If I'm at B, be at B. Then I can assure you that you'll be able to understand all of this. Obviously, for all of this, it is understood that you must be sitting at a serene place where you don't have anybody else around, like your parents, your friends, or probably your siblings who are there to disturb you and take away your attention. Moreover, devices like mobiles, televisions, laptops, etc. also must have been put aside so that there is nobody which is inanimate also to disturb you. Okay, so now let's come to trying to do the sum. So we get to see here that we actually have log of QR to the base P, which has been given to us to be A, right? And then we have log of PR to the base Q, which has been given to us to be B, then log PQ to the base R, which has been given to us to be C. And then we have to prove, rather we have to find out the value of 1 upon 1 plus A plus 1 upon 1 plus B plus 1 upon 1 plus C, right? And we've got to check which option out of each of these four is the correct one. So first, children, as we've been given the value of A, B and C, that is what we're going to substitute in what has been given to us, and we will try and calculate the value. So if in times to come there are certain rules of logarithm which are required, obviously that is going to be applied, right? Now here, keeping the value as we require to find out the value of 1 upon 1 plus A, to which is to be added 1 upon 1 plus B, and to which is to be added 1 upon 1 plus C, right? Now we keep the value of A, B and C, so as such we will now have 1 upon 1 plus, what is the value of A? It is log of QR, which is to the base P, right? And further to that then is added 1 upon 1 plus B is what? It is log of PR to the base Q, right? And to that is further added 1 upon 1 plus C. So it's 1 plus log of PQ, right? Which is to the base R, right? And this now has to be simplified. Okay. Now I'm sure you people must be knowing that if we talk about the logarithm of a number, where that number is the same as the base, then the value of this is going to become equal to 1. Now what I'm wanting to say is, if you talk about 1, then that's actually equal to log of x to the base x, right? We can very simply convert this in the exponential form and understand this. That is, we will keep the base to be the same, and then we will exchange the top entirety, that is x raised to the power 1 will become equal to x, and this is perfectly true, right? And that is the reason why when we talk about log of a specific number, when that specific number is also the base, then the value of it is going to become equal to 1, right? So this is how we will convert these ones, but obviously they are going to be different in every fraction's denominator, right? Because in every fraction the condition is different. So as you can see, in the first fraction's denominator, in the second term, we have the base to be p. So it will be best if we can now write this to be log p to the base p, so that the bases can be kept to be the same in both the terms. Now to this is added log of QR, which also has a base of p, right? This in times to come is going to help us. Now to this is added 1 upon 1 plus log of PR, which is to the base Q. Now we also require to convert this 1 in terms of log Q. As such, we will say that this is log of Q, right, which also has a base of Q, right? And that's again going to help us because the base of both of these terms is Q, right? A rule of logarithm will get applied. Now the third term, children, is 1 again, where now we've got to bring it in terms of R. So as such, we'll talk about log R to the base R, right? And to which is going to be added log of PQ, right, to the base R. Next now children, what we do is we know a rule of logarithm, that is, if we talk about log of a b, right, then that becomes equal to log of a plus log of b when both of these have the same base. So if we talk about the base to be c, then we will have this to be log a to the base c plus log b to the base c. Now here, if you look up the denominator of the first fraction, we find that the base of both the terms in logarithm is exactly the same, and as they've been added, so what will happen is, of whatever's logarithm they were finding out, they will get multiplied. That means you will have log of p into qr to the same base, which is p, like earlier it was c. So this is what we're going to now do in the next step. So now we have 1 upon log of p, which is going to be multiplied with qr, right, and the base will remain to be the same, and here we've just used the rule above. Now to this is going to be added the next term, and the next term will be similarly written as, now it can be written as log of q, which is going to be multiplied with pr, and the base is going to be q, right. Now to that is going to be added 1 upon, again converting this binomial to a monomial, we will now have this to be log of r, which is going to be multiplied with pq, and the base is going to be the same as the base of both of these logarithms. Now I hope you can understand why is it that in the first term the base for making 1 out of log was taken to be p. Now for making 1 out of log, right, was done by keeping the base to be q, because here there is q and earlier here there was p, and similarly in the third term there is r, and as such we wrote the 1 to be log r to the base r, right. Now children, continuing with this further, we get to see that we have some 1 upon log pqr to the base p, right. So this can be further simplified as just writing this as log of pqr to the base p, right, which is added to 1 upon, again you can write log of pqr. That is because if you change the order of the numbers multiplied, it doesn't matter, because multiplication of numbers is commutative, that is the order is unimportant, right, remember this. Now this is to the base q. Now for the third term we have 1 upon log of, again we will have pqr, right, which is to the base r. Now here children, I'll quickly tell you people a rule which will help us out, and that rule is this, that if we talk about log of a to the base b, right, and if say we talk about multiplying it with log of b to the base a, right, then the product of both of these is equal to 1. Or in other words, what we can say is, if we talk about log of b to the base a, it can be written to be equal to 1 upon log of a to the base b. So you can just understand this and remember it this way, that if we have log of a number to a specific number as a base, then we'll have it to be equal to 1 upon log of the number which was the base, right, and log of what number? The number which was the base, and the base to be the number of whose logarithm you found out. That is, we have just reversed, or we have just exchanged their positions, right. Now this comes from a derivation, which in times to come I will discuss just now, because you should not be having any ambiguity. So we'll now be using this rule to solve this sum first. So the next step now, what we can do is we can now write this as this, that we have, that is 1 upon, we can write again 1 upon log of p, which is to the base pqr, right, as we know that if we talk about exchanging the number whose logarithm we were finding out and the base, right, then it's actually the inverse of each other. So if we have log of pqr to the base p, then it's going to become equal to 1 upon log of p to the base pqr, like what we looked up here, right? And now if you talk about the second term, in the second term you will now have here in a similar way 1 which is going to be divided by log of now q, right, to the base pqr, right? And to that then is going to be added 1 which is going to be divided by log of r, now the base is going to be pqr, right? So this is when you reciprocate the fraction, right? Now further, now you get to see here that this is something like a upon b which is divided by c upon d. Now when you have something like this, that is, there is a fraction which is divided by another fraction, you tend to get confused as to which will come in the numerator and which will come in the denominator. So this confusion regarding the terms of the ratio is now going to be removed by writing the first fraction first, and then in place of this division sign, which is the whole denominator sign, we will actually write the division sign, and then we will write c upon d, the next fraction. And this is actually what this means. And this meaning is now further going to be simplified as a upon b. The division sign will be converted to multiplication sign, and further we'll have the reciprocal of the fraction which is next, that is d upon c. So here, to children, when we do this, we will get 1 which is going to be divided by 1 upon log of p to the base pqr, right, to which is added 1 which is further divided by 1 upon log of q to the base pqr, right? And further again to that is added 1 which is divided by this division sign. We have to write in this way, that is, we have 1 which is divided by 1 upon log of r to the base pqr, right? Now as we have this 1 divided by, so obviously in the next step it will become 1 into log of p to the base pqr, right? That is 1 into log of p to the base pqr, right? And this is going to be divided by 1 as was the numerator. Now to this is going to be added 1, right, into, again now you will be writing the reciprocal, that is log of q to the base pqr, right? And further, then the last term is going to be 1 into, again, the reciprocal, that is log of r to the base pqr, right? And this is going to be divided by 1. Now as 1 is multiplicative identity, so the one that we have in the numerator as well as in the denominator, right, will vanish into thin air, and you will just be left out with this term, and this term, right? Okay, so here thus what we do is we are now going to write just this, that is log of p to the base pqr, right, to which is going to be added log of q to the base pqr, and to that then is going to be added log of r to the base pqr. Now children, we just now looked up a rule, that is, if we have the base to be the same, right, like if we have log to the base c and log to the base c of two different numbers, and between the logs of both of the numbers there is a plus sign, this actually is log of a into b. That means log of the product of the two numbers whose log we were finding out to the same base, right? So this is what we can do even when there are 3 such terms which are in logarithmic form. Okay, so as such, now here you will have log of the first number p, which is going to be multiplied with the second number q, which is further going to be multiplied with the third number r, and as the base is going to remain to be the same as these 3 numbers, so as such here we will now be having log of pqr, right, to the base pqr. And we've also looked this up, that is, if log of a number right, and the base are exactly the same, then the value comes out to be 1, right? We just looked this up. So this rule is again what we'll apply. So as such, we will get the final answer to be 1, and which is that subpart or the choice that we're going to make, which tells us that it's 1. It's actually the fourth one, right, which is true. So as such, here finally you will write the answer, that it is actually the fourth option, and in your OMR sheet you will actually be marking 4, right? So children, I'll just quickly discuss this again. Here in the question, we've been given that we have to solve a multiple choice question, and as it will be a multiple choice question, so obviously you won't have to write such a lot of steps, right? After understanding it, you can quickly do it. Okay, so you have been given log QR to the base P is equal to A, log PR to the base Q is B, and log PQ to the base R is C. Now you're going to prove, rather you're going to find out the value of 1 upon 1 plus A plus 1 upon 1 plus B plus 1 upon 1 plus C, which is to be equal to any of these 4 values. So initially when you just have a look at it, right, you can't just do hit and try, because you won't be able to understand whether each of these is actually coming to be 1 and thus they get added up to 3, or probably each of these are 0, as such the final answer is 0, or probably if you talk about them to be 1 upon 3, right, and or they are 1. So you're not getting a hint as to what the answer is going to be. You actually have to solve this out. Now that here we have A, B and C in the denominator of these fractions, and we have the value of these A, B and C, so that is now what we're going to substitute. So we keep the value of A, which is log of QR to the base P, right? Then we write the value of B, which is log of PR to the base Q, and finally we write log of PQ to the base R. Now here we have this 1, which is actually distorting the whole process. So what you'll do is you can write this in terms of the base of the other term, which is also in logarithm. So as such, this 1 can be written as log P to the base P, as in the second term you have the same base as P. Now if you talk about the next term, we have this 1 which requires to be converted. So as such, we find that in the second term the base is Q. As such, if we write log Q to the base Q, right, the base will also be the same as the second term, and the value 1 will also have been converted to log. Now why does this become equal to 1 is what I discussed. That is, if you talk about log of x to the base x, that becomes equal to 1, because if you try to write this in the indices form, then the base will remain to be the same, and then it will be raised to this index, which will give you x, right? And as this, you know, as perfectly correct, and as such we can say that we can do this in each of these 3 cases. In the third case, again we can write this to be log R to the base R, because here in the second term the base is R. Now children, we know this, that if we have log of AB to the base C, that is actually log of A to the base C plus log of B to the base C, right? That is, the base remains to be the same, and both of these numbers which were in product, right, you will be writing a sum of the logs of these 2 different numbers. So as such, here now that we have the sum, so now we will write the product of the terms whose logs we were finding out with the same base. So now we have log of PQR to the base P, right, and here we have log of Q into PR to the base Q, right, and then here we have log of R into PQ to the base R. Now children, if you talk about PQR, it becomes PQR. If you talk about Q into PR, Q can be rearranged so that it becomes equal to PQR, because multiplication of numbers is commutative. So if you talk about 3 which gets multiplied with 4, which further gets multiplied with 5, can also be written as 4 into 5 into 3, right? As a multiplication of numbers is commutative, in both of these cases you'll get the answer to be the same, right? There are certain entities in mathematics where when you change the order, then the answer doesn't come out to be the same. So have you guessed those chapters? If you've been able to guess it, then do write it in the comments. Which are those chapters where if you change the order, then the meaning changes, right? Okay, now here what we have done is we found that we are finding out log of PQR in all of these three denominators, but in the first we have the base to be P, and in the second we have the base to be Q, and in the third we have the base to be R, right? So next what we do is we now talk about the log base change formula, right? So I'll quickly try and explain this to you. That is, if you have some, say, log of A to the base B, right? Now if you want to write this, you can write this as log of A to the base C, which is divided by log of B to the base C. That means you can put up a common base, and you can just remember this way, that whatever is coming above will remain in the numerator and whatever is below will remain in the denominator, right? So this is what this is, the log base change formula. Now this has been used here, and how is it that it has been used? That is, if you talk about here log of B to the base A, right, which is multiplied with log of A to the base B, right, their product becomes equal to 1, because here also we can apply this. Just see, I will do it where I'll just push a little that side and then I'll show you. Okay, so if say now we talk about log of A to the base B, which is getting multiplied with log of B to the base A, right, how does it become equal to 1 is what I'm going to show you now. Now let us say that we can now write this as log of A, right, to the base F, which is divided by log of B to the base F, right? We've just now looked up that by the log base change formula we can do this. Now if you talk about the second term, we can write this as log of B to the same base F, which is divided by log of A to the same base F. Now choosing this base was our choice, and as such we've taken to be F for both the cases so that things can be simplified. Now we get to see that there is this log A to the base F, which will get cancelled with log A to the base F, and log B to the base F will get cancelled with log B to the base F, and as such it is going to give you the product of just 1, and that finally is going to become equal to 1, and that is the reason why here you can write this expression as log of B to the base A, right, or multiplied with log of A to the base B is equal to 1, and from this you get this expression that log of B to the base A is equal to 1 upon log of A to the base B, right? So as such here each of these are now similarly written, that is, we write this as 1 upon log of P to the base PQR. This is written like log of Q to the base PQR, and here also we write log of R to the base PQR. Now as this is just like one fraction which is divided by another fraction, we'll convert this whole division sign to the actual division sign. So this is the whole denominator sign, right, in place of which we can write this division sign. And in the next step, as you must have learned in bot maths, what we do is we now write the fraction which comes after it, its reciprocal. So when the division sign gets converted to multiplication sign, then the fraction which comes after division will actually get reciprocated when we use a multiplication sign in place of division sign. So we'll have A upon B into D upon C. Same here, we will have 1 which is divided by this term, 1 which is divided by this term, 1 which is divided by this term, and then we will now be reciprocating the fractions by first converting the division sign to multiplication for all of these three cases. Then now we now have only the numerators which remain, and we find that each of these three terms are such that their bases are exactly the same, right? And here we are quickly reminded of the rule that we studied earlier, that is, if we talk about the log of a product of two numbers whose base is C, then it will be equal to the sum of the logs of those two numbers which were in product, keeping the base to be the same, right? So as such here, as this already is there, so now we can write the left hand side, that is, we can now write this as log of P into Q into R, right, which is to the same base PQR, right? So as we also learned that if we find out the log of a number whose base is also the same number, then we get it to be 1. So this again we apply, and now we have log PQR to the base PQR, which becomes equal to 1. And if you check up the options that you have in the multiple choice question, then you find that the fourth choice is the one which matches your answer. As such, finally you will now write that the final answer is actually 1, which is the fourth option. Okay, and in your OMR sheet, that is the optical mark sheet, right, what you'll do is you will register 4, and I'm sure you will get full marks. Now, as I did it with all the steps and did it slowly, so obviously this took time. So this shouldn't overwhelm you that this is pretty tough and this takes a lot of time and I have very little time. No, when you do it in practice and when you don't write these formula, etc., you do it in rough, almost by this method, right, and by practice it will get further shortened, then you'll be able to do it in optimum amount of time. Okay, now all of this was done with you people. Is all of this clear? So if you've been able to understand and there was some special thing that you learned here, right, make sure you write that in comment. And if you've been there till the end of this lecture, I'm sure that you must have liked this. So obviously there is this that you should also share with the other aspirants so that they can also be able to understand logarithm with ease now. Moreover, this is not the end of logarithm, right? If you want more of logarithm, there in my profile you will find that there is a Google form. Just write that you require more of logarithm. I will ship more of logarithm to you, right? So there are many resources which I can share with you, which can make you excel and which can actually make you qualify this foundation quantitative aptitude test, and I'm sure you will make it if you study seriously. Moreover, children, there is also an option of a live class, as I take regular live classes of mathematics, which is more participative. It is one where you can take the onus as the teacher teaches and you get to see the teacher and you are able to understand and perceive much more in real time, as it is going to be live, right? And don't shy off from thinking that this is going to be costly, because you're going to make a lot of cost after you become a CA, right? Or for that matter, if you become an officer in the Army, Navy, Air Force, or probably some bank office or anything, any exam that you're able to qualify, obviously you're going to make a lot of money. You'll be making a lot of social reputation and a little price, for which the live classes are going to be taken is something which is paltry, something which is very much infinitesimally small in comparison to what you will be achieving. So make sure you join me in the live class where I share all the insights about all the different topics and where I will hold your hand and make you succeed in the CA Foundation numerical aptitude test, right? So this is all from my side. Saurabh Kumar Dutt signing off, and I hope to meet you people, and make sure you put up your best and qualify this time. Best of luck.